Price elasticity of supply measures how far producers can stretch their output when prices go up. Imagine a toy slinky dog trying to reach a high shelf. The shelf represents a higher price, and elasticity measures exactly how much he can physically stretch his middle to get there. We calculate this stretch using a specific formula, the percentage change in quantity supplied divided by the percentage change in price. Because producers seek higher profits, when price goes up, suppliers increase the quantity they produce. Thus, our formula typically yields a positive number. Unlike demand elasticity, where we wonder if consumers will pull away from a price increase, supply elasticity assumes the producer wants to chase the higher price. We are measuring their physical ability to increase production to catch it. Let's apply this to a toy coin factory. The market price for these coins rises by 20%, jumping from $10 to $12. In response, the factory ramps up production by 40%, going from 100 to 140 coins. We plug those percentages into our formula. We take the 40% increase in quantity supplied and divide it by the 20% increase in price. That gives us a result of 2. Since this result is greater than 1, it means the producer is highly responsive to the price change. We call this state elastic. The factory was able to stretch its output to capture the extra profit. Look at graph B. Notice how a small movement up the price axis results in a large leap forward in quantity supplied. That is elastic supply. Now compare it to the steep slope in graph A. Here, the price can climb significantly, but the quantity supplied barely nudges forward. This rigid response is inelastic. We can see the theoretical boundaries of this concept on these two graphs. Graph A shows a completely vertical line, meaning supply is perfectly inelastic. The quantity supplied doesn't change regardless of price, giving us a value of 0. Graph B shows a horizontal line, where supply is perfectly elastic and the value is infinite. By comparing the slopes of these curves, economists can identify whether a specific industry is flexible or constrained by its production limits. Let's test this. If the price of a spaceship increases by 25%, but the factory can only increase production by 5%, what is the price elasticity of supply? Pause the video and calculate the answer. 5% divided by 25% gives us 0.2. Because this number is less than 1, we classify the supply as inelastic. Spaceships are inelastic because of the physical barriers to making them, such as production speed. It is fast and cheap to manufacture more pencils, so pencil factories are more elastic. However, it takes years to grow an apple tree, which makes apple harvests relatively inelastic in the short term. Another factor is storage. If a product is non-perishable, a company can stockpile it in warehouses and quickly release it when prices rise. Perishable goods, like fresh milk, have a limited shelf life, making their supply less flexible. The time period under consideration also matters. In the short run, a factory is limited by its current machinery and floor space. Over a longer period, that same company can build new facilities, making their supply more elastic. An inelastic score of 0.2 is a mathematical reflection of physical constraints like time, storage capacity, and production complexity that a business must work around. To reach high elasticity, a producer typically needs a long-run timeframe, easy storage capabilities, and quick production methods. This cable organizes the thresholds we've discussed. It maps the formula to the 4 states of elasticity, their numerical values, and curve shapes. Take a screenshot for your notes. It's a quick reference for solving elasticity problems. Understanding these variables allows us to analyze how different industries are likely to react when market prices shift.